Hello, everyone. Thank you for being here for this Malt Academy. Before we start, can you tell me in the chat if you can hear me and see me, and the same for Chad, please? Okay, great. Thank you. So nice to meet you. I'm Alexandra. I work in the community team at Malt, and I'm in charge of the freelance coaching and animation. And I also help to coordinate the Malt Academies. So today it will be Chad Carlson, the manager of the DevRel team at Platform.sh, who will do us the honor of hosting this Malt Academy to tell us more about application performance monitoring and profiling with Blackfire IO. So while waiting for everyone to connect, I will give you a quick introduction to Malt and to the Malt Academies and how the Malt Academies work for those who wouldn't know. So the Malt Academies are being proposed by Malt to allow the community to have a quick access to training, to talks, and to be able to learn about different subjects, either presented by freelancers or by external speakers. And for those who wouldn't know Malt, it is a platform for connecting freelancers and companies. So we are lucky enough to work with the largest community of freelancers in Europe, with over 3,020 freelancers now. And we are present in France, Germany, Spain, Belgium, and the Netherlands. And we work with more than 90,000 clients, including 80% of the CAC current, but also with small and medium-sized businesses, etc. So if you're a freelancer, you can find new opportunities thanks to Malt, and you can grow thanks to our community and our various partnerships. So I'm going to leave the floor to Chad. Don't hesitate to ask your questions during this conference in the question tab, which is at the bottom right, just next to the chat, if you have any. And Chad will answer regularly during his presentation. And you can also interact during the session in the chat tab. Best Malt Academy to all. And Chad, I leave the mic to you.
Hey, it looks like I'm already enabled. Hey, everyone. Good to be back. My name's Chad Carlson. I am from the DevRel team at Platform.sh. Platform.sh is in part, a platform as a service and a DevOps platform meant for deploying enterprise-grade secure applications to the cloud and creating a space that makes it very easy to provision infrastructure with infrastructure as code configuration and provision development environments that actually are true staging environments with production data. That's not really what I'm going to talk about here today, but it's related. So the last Malt Academy that I did was all about GitOps and how you can get your organizations into the space of iterative development and more easily being able to try out new ideas without blocking pressing updates that may have to be applied to your applications. And so Platform in many ways exists to try and help solve that problem for teams. But there's another component, I think, to production web development, and that's application performance. It's important for a number of reasons that I was planning on talking about today, but it's relevant to who I work for, Platform.sh, because we recently acquired a tool called Blackfire.io, which all in one package is both a application performance monitoring solution. It contains a profiler, and it enables performance testing to be committed to your repository so that you can prevent performance regressions on day-to-day from falling back from when you happen to dedicate sprints of your development lifecycle to tackling performance issues. It actually makes it so those can't be reintroduced. So that's what I wanted to talk to you about today. It's just what we will narrow down to as is a continuous observability strategy and how Blackfire handles that and what that looks like. Here's a picture of me, again, DevRel team at Platform.sh. I think some links will be shared later in the talk for Platform and for Blackfire and some of my information. So feel free to reach out if you think of a question once we're done, and I will be happy to answer the best I can or direct you to the right person. Um, so the structure of this talk has got these 5 parts. So why you should care building the performance of your application nowadays. And then when we get into Blackfire and how it tries to tackle the problem with basically the parts I already described, a application performance monitoring solution. How do we monitor our production app to find out where and when something might be going wrong in our application that isn't directly observable without a tool like this? Profiling. So how can we take notifications and insights from the monitoring portion of our continuous observability strategy to narrow down why problems are occurring and drive down to exact function calls and events that occur during requests in our application. And then performance testing, which says, okay, we've done all this work of the first half of our performance lifecycle and our strategy to figure out that something has happened and it's happening here in our code. How can we take that information to now enforce a performance budget in the long term so that we keep improving the performance of our apps without ever falling back for some feature that's introduced in the future? And then lastly, I wanted to finish up by just saying, you know, there's plenty of fairly obvious reasons why you should care about application performance that are often business centered, and those are totally important for your clients and clients that you will collaborate with. But there's also other reasons surrounding that, specifically around the resources that our applications are using and uh, making sure that our businesses are environmentally conscious and as green as possible by gaining insights like this, and how it provides a tool to actually make conscious decisions when you have them in hand. So why you should care about app performance. When we talk about DevOps, sort of how I described platform, I have a production application, and at different times during its lifespan, I'm going to introduce many new features. I may change my infrastructure slightly, and I'm going to have to deal with security updates. And so I have to, in some way, whether it's somebody like Platform or with something else like Terraform or another platform as a service provider, I have to figure out a workflow that allows me to create as close to production copies as possible, real staging environments to test these changes when they arise. And hopefully in a way that all of the members of my team can collaborate and contribute to this end goal of this site can't go down. The experience inside the site needs to be as uh, positive and really intuitive as possible for the users that we already have in our ecosystem visiting the site. Um, and it should probably also support our desire for growth in business and growth in the number of users that visit the site and create accounts and actually interact with our application. But there's clearly a very large gap between a site that never goes down and a perfectly performant app. And so when we deploy something online, how confident are we that while it may not be down or down often, how confident are we that we're close to the other side of the spectrum, that we have the most optimized application that we can? How confident are we in our ability to write code? And hopefully, if we're all honest, we've been programming for quite some time. We all have a varied amount of experience deploying things online. But if we are honest, we could say there's probably something overlooked in trying to get a particular feature across, or there's some reliance on dependencies and previously written code that's instrumental to our business logic that it probably isn't. It probably sits somewhere in between up a satisfiable amount of time for our business and flawless that we sit in, and there's room for improvement as far as performance is concerned. Um, so depending on where you deploy, finding where performance improvements can 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 be applied and where the performance bottlenecks are in your application can be pretty complicated. I mean, in my last Malt Academy, I showed this figure uh, in the context of deploying staging environments and just how much infrastructure and communicating parts that there are in the recommended how you deploy WordPress on AWS figure. And there could be non-optimal code at pretty much any of the nodes in this figure. And so how do we um, close that gap between flawless and its current state without a tool in our toolbox that allows us to narrow down all of the calls that occur connecting all of these nodes? And how does that fit into our current workflow? So it's not just about can it be performant, but how do we prioritize performance in a certain way that it becomes a daily part of the way we do DevOps as teams? Um, so how do we measure performance in the first place? So we can't optimize anything that we can't measure. Um, we can't understand where performance may be needs improvement if we are relying on black box code from open source frameworks that we may not be writing the most performant incompatible code of interacting with those or with the services that we use. How do we better understand outages when they happen and detect them? And before they happen, how can we detect that resources are being consumed in a way that highlights that an outage is likely to occur because of this increased traffic, for example? Um, how do we take this pipeline that we have for development environments and leverage it to identify and catch performance regressions? I mean, we can imagine the snowball effect of our code is at a certain level of performance, however we might measure that. And then with each new feature, we're adding more and more code that, at our best effort, still could contribute to a little bit more load time for the user each time, and it can build on top of each other. How do we prevent that cascading effect from happening? Um, and with this information, should we have it, like, can we set a budget for what is the maximum load time allowed for a given page as far as it's coming from our backend applications? We have plenty of tools for looking at front end load time, but when it comes to the functions that are called, the transactions that occur to serve an API, for example, like what's tolerable? Are we able to enforce a budget like that in a deterministic and repeatable way, like we would development environments and infrastructure, like everything else that we need that kind of coverage for? And like I said, how confident are we generally about the code that we write at any given time? Is it just humans? Is it just experience with other members of our team as far as what optimal performance may be for a new feature? We really need other tools at our disposal here. And so this is where Blackfire is really, really helpful. There are other application performance monitoring tools. There are other profiling tools. There are other performance testing tools. Blackfire is unique that it's a space in which each of these components leverage information from the way that they take measurements of what happens in your application, production and otherwise, in order to create a continuous observability strategy for your team. So I need to get notifications about um, when and where something may be impacting my production code base, take that notification to begin directing my attention to some more deep dive investigation to figure out, okay, it is for sure happening here in my code base, to translate those insights and what we fixed in our code into something that prevents from that point forward, based off what we've learned about how our code actually works, into something that can't be bypassed in our CI pipeline. And so that's really what it tries to do, is it closes all the gap together into a single loop, a single strategy for combining each of these tools together. So the plan of this talk, I guess, is to look at the information that can be withdrawn from each one of these components, and then how it sort of builds the strategy altogether. Uh, I know on my last one the replay was available, so I'm assuming that's the case, Frederic. Any other questions before I go forward? It looks like she's answering. So what's Blackfire look like? How does it work? Essentially, if you imagine that this blue faded square is our production application, um, it needs to contain a couple of pieces of software inside of its runtime. And on Platform.sh, those come pre-installed and easily enableable. And that's a probe and an agent. So if we talk about PHP, that is something that's installed in the PHP container, and it's enabled with a PHP extension. And then from there, the Drupal application is able to communicate with the Blackfire main server. And so what we can do is we can leverage a few calls to trigger investigative events like a profile, which we'll get into with, like, say, a browser extension that will communicate with the agent probe that will then send information to the Blackfire server, in which case it'll be able to map out every single call that happened in the request that you profiled, for example. And so these are the pieces that communicate with each other to make Blackfire work. And so we can first get into monitoring. And so what I'm going to do is I'm going to show you sort of what the dashboard looks like. So here actually is the Blackfire monitoring dashboard for our accounts API at Platform.sh, which is a Drupal site. And so as you can imagine, that handles quite a few requests. At Platform, we allow you to say that a Git repository is a project, and within that repository, commit a few files that provision pieces of infrastructure like PHP 8.0 and MariaDB 10.4 to build up a cluster of containers that describes an environment for a branch. And your default branch deploys as the production site. And then each time that you create a new branch, you create this exact staging environment. So that's projects. That would be like the project API, if you will. But then everything about how you how you set access control across those environments, which developers can access which types of environments, who actually gets access to the production environment, gets inherited alongside this branching abstraction in our API. But how those users are created comes from this accounts API. So each person is what we would call an organization, and they can oversee many, many projects and be granted access to both projects and individual environments. And so this gets called all the time. It's like one huge half of our API. And so what this, let's see here. I'm going to go back to the main page. So for the monitoring dashboard, what it's going to do is for a specific window, which in this case is today, for this last hour period right before we started, it's viewing real live traffic on our production API. And from this page, I can begin to view things that are pretty detailed about what happens to that traffic when it begins to interact with my application. So I can say things like, I want to figure out what GET requests are doing when they reach the accounts API. I see that 22,000 of those requests end up with 400 requests. I want to investigate what's happening there. And while some of them are quite short amount of response time, I do have 20,000 requests that are on the 100 millisecond range response time. And so I can add these features to say, for my entire accounts API, what is going on resource-wise for 400 type requests, GET requests, that are taking this amount of time? And is there anything that can be improved there? I can see how that global response time has evolved over course of the window that we've set here, which I can extend to days in the past. I can say for the last 24 hours, what those response times look like, and also figure out which parts of my application, which calls contributed most to this response time for this particular request. So either I can keep it very, very wide net general to begin with, and then say, I think I want to investigate why is it that GET requests in the last hour have this much more 400 responses and this amount of uh, response time. And so from here, I can narrow down the scope to the types of requests from this wide net of what requests were placed in the last hour. And so from this information, I get down to this bottom section here. Maybe zoom in a little bit. In this case, it's telling me that in my whole API, I have many, many transactions that are happening. And of those transactions, these are the top 6 that had the highest impact on the performance of my application. And so this is accumulated from 10 very short traces through the application on live production traffic, and they are relative to each other. So these 6 calls have the greatest response time and memory usage for the app relative to each other, such that the greatest impact is this first request right here, going to the main platform endpoint. And so from here, I'm seeing a lot of the same pattern, 400 requests at 100 milliseconds. And I can associate that transaction with specific calls to services inside my cluster. So this is connected to a project on Platform. And so from here, I can say, okay, it seems like the greatest impact transactions that I'm monitoring on my production app have to do with when my application interacts with Redis, when it tries to handle caching. And so I'll see here that service call that has 50% impact and almost 900 calls during this period. And I can see some of the span of how those calls cascade on top of each other. And what we'll get into next, the profiles that helped make up these measurements. So this is helpful because I can start to get an idea of when something is going on, because I can set up notifications for these. I could say for every 1 hour span, I want to know if a particular endpoint is continuing to provide the greatest impact to poor performance on my application. I can every day get what's called a health report, which tells me, okay, here is the average response time. Here are the number of requests that I've gotten, the number of errors that have been triggered inside my application while handling those requests, and how the most impactful transactions have evolved over time for my application. So here we'll see that the most, just like before, the most impactful transaction is this API platform endpoint, where since the last time we've measured, since the last window, it's actually increased in impact 1.5%. It's gotten more requests, but this is still an impact that we should probably start paying attention to. It hasn't adversely affected the accounts API from staying online, but maybe this is something that we now need to set aside time on our development team to investigate this specific issue, because we know that it's something that's contributing to response time, resource usage and increased response time for our users when they're trying to hit this endpoint. And that gets further pulled up from gradually degrading transactions. So we'll see, just like I said, API platform has a 5.05% impact relative to every single one of these metrics of performance. But we also have this one here. So this is a reports sales endpoint that's internal, but this is probably reflective of something else in our code that is calling this endpoint that is cascading down to this massive performance deficit inside of our application. I think that that's all I wanted to show within this pane, but the basic idea would be, as far as notifications are concerned, I'm going to get an email for every week or every couple days that's going to give me this quick insight of how my production application is doing. So which transactions are the most impactful And more importantly, which of those transactions that are becoming more impactful over time that really should be directed into some investigation from our team. Are there any questions so far about the monitoring portion? We're all sort of familiar with application performance monitoring. Hopefully this has showed you, especially with the filtering of how is it that I can take an alert or a health report and get really fine-grained in terms of the types of requests that I'm concerned with that may be degrading performance. I don't see any questions. Nope. Okay, so I'm going to go ahead and move on to the next section, which is actually profiling. So we have some information of a particular request, a particular service call from our application to the rest of our cluster, to the outside world potentially. So what do we do with that information? We want a direct effort of our development team. Fine, but what do they do now? So let's say they're on platform and they've actually deployed some pull request version of our site. So here I have a Drupal 9 application that's been initialized with the built-in Umami profile. It just gives us some base data, a couple templates that give it some styling and some basic configuration so that we can verify our deployments work for our example code. But in this case, let's say this is our production application and it's a recipes site and has a blog within it and some basic accounts. And I've just found out that we're having some performance degradation and I've set aside a development team to investigate. So what do? Well, they can leverage the configuration that's already inside of here, like I said, the agent and the probe, to run a profile. And so what this is going to do is in this isolated environment, it's going to do a deep trace of this homepage, every single transaction that occurred between the request and the fulfillment of the request. And so we'll see here some really top level highlights that we can go into. And two main views of looking at the measurement we just took. So if we start with the timeline view, we are able to see from the initiation of the request to the fulfillment, the calls that were taken and how long they took. And we'll see right away that sort of in the same way that we pulled out from the accounts application, which was also Drupal, we have some larger amount of impact within our timeline view for our calls to Redis. And they may not take a ton of time, they're only at 5 milliseconds, but they do have an impact on the amount of memory usage that's going on inside this application. So okay, that's something that could be contributed to overall response time for every time that it's called internally. From this information, we might want to go to this extended view, which is the call graph. And so from here, the same thing. It's going to give us a path from the start of the request to the fulfillment of the request and every transaction that had to occur internally in order to complete it. So we go from our main function, potentially go down this primary call path until we get calls to Redis. We have another one here to Redis. So here, these are only called twice. They take less than 10 milliseconds, and they take about a megabyte of memory. So it's unclear of how much that we might want to improve this here, but it does place some influence on the length of time that other calls inside of our Drupal application take because they rely on this transaction. And so we can begin to work our way up this call graph to find bottlenecks inside of our business logic and poor performance here in our code. And then with this information, we could say, okay, it's not just the transaction that occurs in production. It's this specific function call that could very well be called 100, 200 times when it really only needs to be called 1 or 2 times, like a query to the database, that will allow us to point that development team's effort into improving that particular segment of code inside of our application, rather than just giving them the abstract ill-defined optimization goal of improving the performance of our application. From this profile, we get a general view of what the performance of our app is in terms of response time, I/O weight, CPU, and memory used. Um, and this can be helpful for doing exactly what I just described. And when we take that profile, it's also going to come built in with some recommendations based off the framework. So when you don't set any settings in your PHP ini file, so your PHP runtime settings file, we'll see a very long list here, and it will detect that we're running PHP, and it will detect that we're running Drupal. And from this information, Blackfire provides recommendations that are performance focused. So here we have two that are specific about how we enable cache in Drupal that aren't enabled on our site right now. And so we can say on board to use a tool like this and have a very quick list of low-hanging fruit of how to progressively improve the performance of our application. Let's see here. Any questions there so far, everyone? Get my notes here. Equal. All right. Sorry, let's check my notes, make sure I didn't skip over anything there. So once we take recommendations like that, we can also go into the caching tab and see how that slowly improved our cache of our application within these couple different dimensions here, and track this over time with notifications as well. Let's see. I think that is fine with me. The interesting thing, I guess, is how we transform this information. So we have monitoring that says, how is production doing? When is something going wrong? And roughly where? What are the transactions that are having the greatest impact on the performance of our production app? And then we can then provision some staging environment and run a profile that can tell us it's specifically here that our attention is required. So in the case I showed here, that would be there is some degradation involved in when we are setting the cache and interacting with Redis inside of our application. And our team may go in there based off the insights from this profile and find that how we're setting the cache for a set of data inside of a transaction is not optimized. And so they iterate on that function, run our CI pipeline, run another profile, and find that we are slowly improving the performance. So then what now? Do we just merge into production at that point now that we've created some kind of improvement? Obviously not. We want to have some model of test-driven development. And that's where I think Blackfire gets really, really interesting. So for this same application that I just showed, which is a Drupal site that I have in a repository on GitHub, I can commit a Blackfire YAML file inside that repo. And what that will do is we'll take, in this case, I've set many assertions that are related to recommendations that Blackfire has specifically made about production Drupal applications. So that will be PHP ini settings, some standard, what's the minimum amount of wall time from request to completed request that I don't want to exceed for any page on my website. And then I also want to make sure that there's multiple paths of observing these tests. So for any site, there's going to be a bunch of content that is visible publicly, but I have some internal accounts logic in my production application that provides extended access to many other features of the application to those that are actually logged in. So I want to make sure that for all of these tests, that the same performance budget is enforced for both anonymous users and authenticated users that come into our app. And so we can configure that with scenarios. So I'll say, I would like this, the tool is called the Blackfire Player. I'm going to go to the root of the site and to some translation, in this case, Spanish, of our site. And I want to visit articles. And I want to visit the admin section. And so I want to visit those in order. Oh, actually, this version of it only shows the anonymous visitor, but I can set a path of requests through my application explicitly inside this committed file. And so from then, I could also include another scenario that's specific to authenticated users and provide some testing username and password that's accessible through a GitHub secret, for example, to run through the same path and hit the admin content section, where in this case, I would expect a 400 response because I'm anonymous, but a 200 response in the case of this authenticated user. And then I can navigate through many other pages that would be inaccessible to anonymous user in this way. And so what does that look like as far as pipelines go? So here's a pull request that I've opened. Here is the environment that I just showed of the deployed staging version of our site for this pull request. But I also see that I have this failure now attached to my Blackfire environment where I run all of my profiles. And what's happened here is I've actually triggered a build, which is the packaging of a scenario and the assertions associated with each step of that scenario that are tested against those individual profiles that I was doing manually. So the pull request is open. Once the staging environment becomes available, Platform.sh in this case triggers Blackfire to go through these scenarios and say, I have one scenario path of anonymous user. It goes from the root page, the Spanish translation, to recipes and articles, to admin sections that it won't have access to. And for each page, run a profile and test these assertions that the responses should be what they are, and that they also fulfill all of these other assertions that are performance-based, which is page speed, PHP production configuration. And so from that information, I've then been able to determine a failure, which is that in this case, I do have dependencies that have known security issues and are vulnerable currently in my production app. And so from here, if this was just a random feature that I was developing, I could use this information to go, oh, I had not yet gotten a ping from upstream that I needed to update this dependency. I can go down into my code and update it in a single performance sprint to just make that security update and instantly improve the performance of my app from this insight based off the assertions that I've written, pulled from recommendations from Blackfire itself. And that's useful, but that's not how we got here. I was monitoring. I took a profile that allowed me to identify a piece of my code that was underperforming, that I've now set aside a development sprint in my team to dig down into, investigate, fix the problem, and introduce pull requests to fix it. So what do I do with that information? Like I said, this was a call to Redis. I think an easier example is, let's say it's a call to a database. We have some account that tracks comments, or sorry, we have a service that tracks comments that are made on all these recipes on my site. And there's access to the database when that happens. Say the thing that we found was that the query that gets all of the comments for a particular article was being run. It's an n+1 query, essentially, that it's being called 100 times when it really only could be called one time. And so we fix that code and we update it in this pull request. I can use this Blackfire YAML file now to create a new assertion that's specific to my business logic. So it can include the name of the function that is providing the data inside this transaction that I've detected is calling the database 100 times, and say, for this specific function that I'm going to call by name, I'm going to define this custom metric that says that function, or sorry, that this metric is associated with this function, and then write an assertion that leverages that metric I just defined to say this metric, which in this case is the number of queries in this function, will only run once ever. And I can even go one step further and say for a given page, for any page, the number of database queries should not exceed 5 for any page. And we can use that as setting this performance budget for every single page of our application. And so you see how this kind of sets up the cycle again. We detect a problem, we narrow down the issue, we write a test that then enforces a performance budget in the long term for our team and for our application. In this case, the test failed on vulnerable dependencies. Like I said, I can go in and update that dependency and move on from there, knowing that I've slightly improved the performance of my application. Any questions there about the performance testing aspect of Blackfire and how that kind of closes the circle on setting this continuous observability strategy for our app? No? Okay. Cool. So now that we have this, what are the consequences of actually taking the time to develop some sort of performance strategy for your application? We share the slides and we get the source of this figure, but it seems pretty intuitive. Any site that I go to that takes too long to load, I'm likely to abandon as well. And so in this case, for this figure, this shows that by the time we get to 2.5, 3, 4 seconds of a page load, we're losing a quarter of our potential or current users on our website. This makes sense. Poor user experience is the death of any application. And so it behooves us to make a part of our workflow a prioritization of performance. That's why the title of this talk is Performance is a Feature. So as many new features as we introduce, there is a performance dimension of that new feature that we are placing inside the code base that needs to be taken into account, that needs to be nurtured and prioritized for every new introduction. And we can even have, like I was saying before, specific sprints and dedicated time that our development team or even a segment of our team performs on a regular basis of just performance motivated updates to our application, because that this becomes such an issue for our business of any sort of performance degradation resulting in a loss of potential customers. One of the more interesting ones, I think, is something to consider. I want to set up a story slightly. So Drupal, I don't know how many of you work with Drupal, but there was a period at the 8.7 release stage where it was determined that for the serializer component of Drupal core, that any, how to say this, for every call to JSON API that relied on serializer entities, that every category, every one of these extended attributes of entities that relied on this serializer was called every single time when we tried to collect these resources. And these responses weren't normalized either. And so excuse me, they were computed on every single request that happened to the JSON API in version 8.7. And this wasn't known at the time, nor was it a part of the 8.8 roadmap. But Blackfire came in as a tool and discovered that this was happening. And so it identified a certain level of baseline performance in Drupal core to narrow down that this was the source of the problem, that something that could have been called once and and work in tandem with some better caching uh, practices inside the use of the serializer. Uh, it identified that that was the source of the problem to make this a major performance improvement between 8.7 and 8.8, specifically because Blackfire was involved. Here's what the view looked like in the call graph for 8.7 to narrow down that it was indeed the normalizing call for the serializer. And again, its relation to how it communicated with Redis and handled caching here in the improvement part. And its result for getting the normalizer for JSON API using the serializer entity was a 74% reduction in response time, and then 78% drop in CPU usage, 26 in memory. Pretty much everything was drastically improved based off of just Blackfire being leveraged and the tools that I just described to investigate not even a problem that was really known to be there from a lot of people working on Drupal core. So these were all very, very skilled developers, not knowing that this decision sometime in the past was resulting into a huge degradation for Drupal. Uh, that would have been not discovered without Blackfire as a tool. So this is what I've already shown. But what's the result of something like this? So let's do back of the napkin math. So if we say that Drupal is 1.7% of all the websites, and whether we're doing headless or relying only on internal calls within Drupal core, JSON APIs, fairly leveraged within all of those websites. Though Drupal has a smaller market share than something like WordPress, it still works out to almost 14 kilotons of energy consumed that has been saved by a 30% improvement in the performance of JSON API. So if we just say there's a 30% improvement as a consequence of this one change, this leveraging of Blackfire, just this whole continuous observability strategy, and 1% of the websites, 1.7% of the websites in the world depend on this technology for their production applications. This knowledge and this fix resulted in this much less energy resource usage globally. So I guess the takeaway here is that whether you're an individual business or a larger software project, having insight onto the performance of your code base can be really non-trivial. So the Drupal project, the Drupal community made an improvement that was really non-trivial, and it influences the performance of all these applications around the world that depend on this software. And so it results in this much less resource usage across all of them. And so whether you're some kind of working for some kind of agency or working for a company that develops some SaaS products, depending on the number of sites that you have in your fleet and in your offering, having some insight on how much resources your apps are using can make some measurable impact on the total number of resources that you're potentially saving from being consumed in the first place, and make a kind of more environmentally conscious business around your prior only business logic goal of having a performant application for the good of UX and the good of your business logic and quarterly goals as far as sales, for example, would be. You can have this parallel goal of how small changes in the adoption of this continuous observability strategy can really influence your organization's contribution to resource usage globally. And so this is another thing that could be taken into account for you and your team, and could very well become a priority like it is for Platform.sh and Blackfire, of being conscious and giving people the tools to make decisions that are based on exactly this dimension, not just the business component of it. This was my final break slide. If there are any questions, I guess I gave myself about 10 minutes for questions. Otherwise, thank you all very much for attending. I really appreciate being invited back from Malt Academy. I hope that this was helpful in getting the smallest overview of Platform.sh and how we think about performance and the DevOps process. And then now how Blackfire becomes like the second part that fits into thinking about regular performance check-ins and notification and improvements to your apps, and why you might want to do that. So thank you again.
Thank you a lot. Anyone has any questions? Okay. Okay, thank you, Arthur. So thank you all for attending this Malt Academy, and thank you, Chad, for hosting it. It was very interesting and complete. If you ever want to see another academy on various subjects, don't hesitate to visit our website, maltacademy.com. I will show you the link. Right here. Okay. And if you want to do like Chad and host a Malt Academy, don't hesitate to send in your topic by clicking on the Become a Speaker button on the same website. And finally, if you haven't seen the beginning of this academy, or if you want to see all the other presentations again, they are available on the replay page of maltacademy.com. On that note, thanks again, and see you soon for another Malt Academy, I hope. Bye, everyone.
Take care, everyone.